Hi, I'm your tutor Andy, and for today's video, we are going to talk about the difference between distance and displacement. Let's examine this picture. If it is a 5-kilometer drive from your home to school, the distance traveled is 5 kilometers. After dropping you off at school and driving back home, your parent will have traveled a total distance of 10 kilometers. Therefore, the distance denoted by D is the total length of the path along which it moves. Now, when we talk about displacement, denoted by delta D, it is the difference in the initial position D0 and the final position DF. So what does that mean? If we ascribe the forward position a positive, so that's positive 5 kilometers, and the opposite direction a negative, minus 5 kilometers, then the two quantities will cancel out. There is no displacement because your parent ended up in the same initial position. So going back to distance, we only include the magnitude, the size or amount of the distance traveled. This is called scalar quantity. However, when we describe displacement, you take into account both magnitude and the direction of the movement, making it a vector quantity. Let's have an example. A cyclist rides 3 km west and then turns around and rides 2 km east. What is her displacement? What distance does she ride and what is the magnitude of her displacement? To solve for the displacement, we must first assign some values. Let's make west a negative value and the east as a positive value, and the middle as our origin. Now it says here that the cyclist rides 3 km west. She then turns around and rides 2 km east. And what we're looking for here is the difference between these 2 points, the initial and the final position. Remember, what is asked here is the displacement, so we have to include here the direction, which is negative. So now we have to look for the total path along which the cyclist rides. Remember that distance is a scalar quantity, therefore the direction does not matter. So that is 3 plus 2 kilometers, total of 5 kilometers. Now the magnitude of her displacement is simply 1 kilometer. Now try to answer this next example by yourself. On an axis in which moving from right to left is positive, what is the displacement and distance of a student who walks 32 meters to the right and then 17 meters to the left? So let's go ahead and draw it first. So moving from right to left is positive, so that means the other way around is negative. Now the student walks 32 meters heading to the straight, so that's negative 32, and then 17 meters to the left, positive 17 plus 17 meters. And this gives us negative 15 meters. For the student's distance, we simply add up the path they walk along. So that's 32 and 17 meters, a total of 49 meters. You always have to remember that distance can never have a direction because it is a scalar quantity. So options A and C are already wrong. And since displacement must have a direction, the correct answer is letter B. Tiana jogs 1.5 kilometers along a straight path and then turns and jogs 2.4 kilometers in the opposite direction, and then turns back and jogs 0.7 kilometers in the original direction. Let Tiana's original direction be the positive direction. What are the displacement and distance she jogged? Okay, so it says here that Tiana's original direction, or the straight path, is positive. So she jogs 1.5 kilometers to that straight path, which is a positive. Then turns around, jogs for 2.4 kilometers in the opposite direction, a negative. And finally turns back and jogs 0.7 kilometers in the original direction, which is a positive. And this gives us negative 0.2 kilometers. For her distance, we are just going to add the path in which she jogged. And this gives us a total of 4.6 kilometers. I hope you learned something today and see you on the next video.